In this problem, all we want to do is rewrite these three scalar equations as a single matrix equation. And if we look at the form of these three scalar equations, we're going to have three variables, x, y, and z, and we have some constant terms. So really what we're trying to do here is we want to write this in the form of ax equals b, where a is a matrix, x is a vector, and b is a vector. Now in this case, let's not confuse x as the vector versus x as that variable, that scalar x. They are going to be two different things. In fact, the x vector I'm going to define right now as x, y, z. Now, the order I put it in doesn't really matter as long as I'm consistent, but I may as well do it in alphabetical order here. It's going to be easier to keep track of. And this is going to be important for how I arrange the coefficients in A. So let's take these three equations, and first I want to rewrite them still in scalar form, but in a practical, consistent order. So I want to reorder them so that my variables are on the left in the same order as this x vector, so the x, the y, and then the z term, and I want to put my constant term on the right-hand side, if I have one. So let's see, this first equation, I have 7 times x, and looking through, there is no y, but I'm still going to explicitly put a 0 there so I don't forget about it when I write my A matrix, minus a 5z equals, now I have a 6 here, I want that on the right-hand side. Constants with no variables, I want to put on the right-hand side. So equals -6. All right, second equation. Again, in order, I want to put the x first. So I have 1x plus 3y minus 2z. And that constant is already on the right-hand side. So that's easy enough. So -8. And then my last one, I have the x term first. So -x plus a 2y. Here there is an 8z. I need that on the left-hand side though, so I'll have a -8z on the left equals, and that 3, I need to put it on the right-hand side because it's a constant. So -3 on that right-hand side. Right, so I've rewritten those three scalar equations in the standard form, and if we look at what's happening here, I have x's down this column, I have y's in the middle, and then my z terms all lined up. And then the right-hand side, again, is just those constants. So what does this let me do? Now I can write it in this nice matrix form, where I've already defined my x as x, y, z. And then on the right is going to be that b vector. Those are just my constants. So if I just go row by row, the first row of A, well, and of B, is going to pertain to my first scalar equation. So I'm going to fill in this matrix. I have a 7, 0, -5. Those correspond to the x, the y, and the z terms. And then -6 for that B vector. Second row, second equation. So 1 in front of the x, 3y, a -2, and then a -8. And then third row is the third equation, so a -1 times x, +2 times y, a -8 times z, and I have a -3 on this side. And again, what I've done is now I've created this A matrix. This is my x vector, which is my unknowns. Now in this case, it's a linear system of equations. I would be able to solve this if I wanted to, equals this B vector over here. I could then use this A matrix and this B vector to solve for x, y, and z for this linear system if that's what I was interested in doing. But for right now, all I want to do is rewrite these scalar equations into this standard form and then put them into this matrix form. From there, I will then be able to manipulate it further depending on what I want to be doing.